So against all odds, Dogecoin is the biggest winner in crypto this week. A little bit of background here. The digital
Hey, did you guys see that? They just found a bunch of Dogecoin on the moon. Let's quickly build a robot and send it there to mine it.
Yeah, here already there's 39 groups that's making their robot to send to the moon. Why not make ourselves one and then we send and get rich?
Yeah, you guys want to ask the group behind?
Oh, sure.
Bro, you want to join us or not?
Okay. To the moon!
The front of Tesla is controlled using the servo motor and has an ultrasonic and IR sensor to detect any objects when moving. The camera is facing the back to leverage the increased stability that the DC motors and the battery provide. It's able to move forward 10 cm and is able to move backwards 10 cm accurately. It is also able to complete spot turns to minimize the turning radius.
So here's a robot. Our robot will be driven by a Raspberry Pi and will be using Python to facilitate communication between all the different components. So using Pi Serial, the Raspberry Pi is able to send instructions to the STM controller to allow it to move. And using a library called PiBlues, we will allow Bluetooth communication between Android application and the Raspberry Pi. This allows it to control the Raspberry Pi remotely. I'll be using a laptop for image recognition. This is done through Wi-Fi and Image ZMQ. With all these components together, our robot will surely be able to go to the moon.
To find the shortest path to mine all the Dogecoins on the moon, we implemented the A-star path-finding algorithm. We first constructed a graph by calculating all the possible actions the robot can make at each vertex. The algo then uses the lowest cumulative cost to find a path to the destination.
With the 7,000 images transmitted from the moon, we then use RoboFlow to label them in preparation for training. We also apply bounding boxes to ensure that the images are recognized accurately. Through data augmentation, we are able to increase semantic coverage of the dataset. Our model is able to learn what the letters and numbers look like, rather than having it memorize the specific way object appears in our training data. This allows us to accurately detect the image ID, even in different lighting conditions, and when the image is slightly out of focus. After pre-processing the images, we then use YOLO V5 to train the dataset.
Come, let's test our latest image rec model.
Yeah, sure. Wow, actually quite accurate, huh?
Yeah, the D also. The image ID is correct, right?
Yeah, D is this 23.
Okay,
wow,
nice.
nice.
Hi, I'm Benjamin, and I'm in charge of the UI.
And I'm ARRON, in charge of the Bluetooth. This is our IR.
Our Android application intuitive interface has been designed with the best user experience in mind, with a tinge of moon element. In addition, our state-of-the-art Bluetooth menu has been created with the intent of ease of use as our main focus. Manual control of the robot is also available if we wish to override the movement control.
Users will be able to place up to 8 obstacles on the map with 1 or 4 directions for the image, and by pressing the image recognition button easily found on the top right, the robot will start the pathfinding algorithm. As the robot traverses the moon, it will be updated on the map, providing a clear simulation of its location. The robot's current status can also be found on the top left, so be able to detect if anything goes awry. And finally, when the robot detects the Dogecoin rock, it will show up on our map as well.
Okay,